Hello everyone, this is Mr. McElveen here. Today I'm going to talk with you about how when we change a dimension of a three-dimensional figure, it affects the volume in a very specific way. So right now we're looking at a rectangular prism. This rectangular prism, being a three-dimensional object, has three dimensions, and those three dimensions are length, width, and height. So we can use the length, width, and height to calculate the volume of this figure. And remember, the volume is how much capacity or how much it can hold if we were to fill it up with water, sand, jelly beans, any items such as that. So taking a look at this one, it has a length that we could probably call 10 inches. The width of this would be 5 inches. And assuming that it's sitting on that little rectangular base, we would say the height is 20 inches. Now with all of these, the length, width, and height are interchangeable. It all depends on how the prism is sitting. So in this case, we're going to take a look at these three. So we're going to calculate the volume. To do that, we use our volume formula. For a rectangular prism, volume is equal to length times width times height. So it's one of the simplest formulas we use. We simply multiply our three numbers together. So we're going to take 10 times 5, times 5 times 20. All right. So we're doing 10 times 5 times. All right, we're having a little bit of technical difficulties. Let's see how this is going to work for us now. All right, so we're going to do 10 times 5 times 20. We're going to multiply all three of those numbers together, and that'll give us our volume, which is 1,000 inches cubed. 1,000 inches cubed. So that's the volume of that figure. So if you had 1,000 tiny little 1 inch by 1 inch square or cubes, it would fill that up. So that's our volume. So what we're going to look at now is what happens when we change one of those dimensions. Okay, so let's take one of our dimensions and let's double it. Let's take our width and say instead of it being 5 inches, let's say that now our width is going to be 10 inches. So I'm going to write that in red so we can see that it's changed a little bit. All right, so now we've got a width of 10 inches. So let's calculate that volume and see what happens. So again, it's just 10 length times width times 10 times a height of 20. All right, so when we multiply all of that together, what we come up with is 2,000 inches cubed. 2,000 inches cubed. So when we compare that to what we had before, our volume before was 1,000 inches cubed, and now we have a volume of 2,000. So what happened to that? It doubled. By doubling the width, the volume itself doubled. So that's just from one dimension. So let's test it and see if that's the only one that it works on. So now we're back to our original prism with a length of 10 inches, a width of 5 inches, and a height of 20 inches. And so we already established earlier that the volume is 1,000 inches cubed. We doubled the width last time and we ended up with a volume that was doubled. So let's test it this time. And now let's take the length. Instead of it being 10, let's make the length 20. So 10 times 2 is 20. So let's see what that gives us. So we're going to change that to 20. All right. So we'll go over here and we'll erase that. And that is 20 inches. So now let's calculate the volume there. So our volume is equal to length of 20 times the width of 5 times the height of 20. And when we do that multiplication, we get 2,000 inches cubed. Again, the same volume as we had previously. By doubling the length, we doubled the volume. So what we learn here is that if you double any one of the dimensions, the volume doubles. So now let's try it with a different prism. So you can see we have a new prism here with a length of 4 meters, a width of 3 meters, and a height of 5 meters. And what we're going to do now is we'll quickly calculate that. Again, length times width times height. So 4 times 3 times 5. So here we have a volume of 60 meters cubed. All right. So what we're going to do is we're going to take one of those dimensions, and this time we're going to triple it. So let's cross through our 5, and we're going to replace that 5 with its tripled value. So 5 times 3 is 15. So remember, when you triple a number, you're just multiplying it by 3. So now what we're going to do is let's calculate the volume with the height tripled and see what we get. So volume is going to be equal to, again, length times width times height. So 4 times 3 times 15. And when we do that calculation, we get 180 meters cubed. So we tripled the height and we got 180. So quickly, and we can do this mentally, 60 times 3 is going to give us 180. So notice our volume is now also 180. When we triple one of the dimensions, the volume triples. And so that's what we're learning about here, is that anytime you're calculating the volume, if you want to increase the volume by a scale factor, all you have to do is multiply it by that scale factor. If you want to double it, you just double one of the dimensions. If you want to triple it, you triple one of the dimensions. If you want it increased by 5, you multiply one of the dimensions by 5. And if you want it increased by 10, you multiply one of the dimensions by 10. That is how you can increase the volume by that same scale factor. So here we are at your notes page. So please take a few moments and we'll fill in those blanks. Remember, if we double one dimension, the volume will double. If we triple one dimension, the volume will triple. If we multiply one of the dimensions by 5, the volume will be multiplied by 5. And if we multiply one of the dimensions by 10, the volume will be multiplied by 10. And something that we really need to remember here is that we are only changing one dimension. We're not changing them all. I'm not doubling length, width, and height. I'm only doubling one of them. So to conclude, if we want to change the volume by a scale factor, all we have to do is change one of the dimensions by that same scale factor.